Dear students, today I am talking about the projection of a vector on a line. Let us suppose that AB be a vector that makes an angle of theta degree in the anti-clockwise direction with respect to the given line, that is suppose L. So this is the directed line L, and AB is any vector that makes an angle theta degree in the anti-clockwise direction with this line L. Then the projection of AB on L is defined as the vector. Let us suppose that vector is P vector. Then the projection of this AB vector on the line L is equal to P vector, whose magnitude is AB cos theta. Means AB vector is a vector makes an angle theta with the line segment L in the anti-clockwise direction. Then the projection of this AB vector on this line as L is AC vector, that is taken here as P vector. Okay, so P vector will be called the projection vector. And what about the magnitude of this? So magnitude of P vector is the magnitude of AC vector, and that will be equal to AB cos theta. Clear? Now the direction of P vector will depend upon the angle theta. If theta is acute, okay, in this case as it is shown, then the P vector is in this direction. And suppose P angle theta becomes obtuse, means the theta lies in the second quadrant, and in that case the direction of P will just get reversed. Okay, also when the angle is greater than 180 degree and less than 270 degree, the direction of P will be in the reverse direction as shown in this figure. But when this angle becomes greater than 270 degree but less than 360 degree, then the direction of P will remain as shown in this figure. How? So let's consider 4 cases. First case is the same. This is the line L and this is AB. Okay, AC will be the projection. AC vector is the projection vector, and AC will be the projection of this vector AB. Okay, this is angle theta. So this is the case. Now the second case, like this, AB vector is shown in this figure like this, and theta is this obtuse angle. Here theta lies between 0 to 90, and in this case theta lies between 90 to 180 degree. In this case the projection will be in this direction. C point will be here, and direction of P will just it will get reversed. Okay, so this is the figure here. Now the third case, when theta is greater than 180 degree but less than 270 degree. This is the vector AB vector here, AB vector. Then the projection of this AB vector will be this point C. So this will be the P vector here. Now let's consider the fourth case, when the angle is greater than 270 degree but less than 360 degree. Then in this case, suppose it is A, it is B vector, then this angle. Okay, so here the projection will become this. It is the point C, and this AC vector will be as P vector. Means the direction of P will depend upon the value of cos theta. If it is positive, then it will be just in this direction, and if it is negative, then the direction of P will get reversed. Okay, so these are the 4 cases you see here. Now let's draw some conclusion from this result that we have obtained. First is, a vector dot p vector. By the dot product of the two vectors, we can write a vector magnitude, p vector magnitude cos theta. Okay, so here you see this is the directed line segment L and this is the vector AB vector. Okay, let us suppose this is angle A and theta is this angle that is in the anti-clockwise direction. Okay, so here you see a vector dot p vector equal to a p cos theta. P is this vector, that is the AC vector here. Clear? So a cos theta, a magnitude cos theta and p vector. This a cos theta will be the value of AC here, that is the projection. So this is the projection. So we can divide a vector dot p vector by the magnitude of p vector, then we will have the projection. You can write projection of a vector on L. So here you see that the projection of a vector A on the given line L is defined as the dot product divided by the magnitude of this p vector. Clear? You can also see that projection of a vector on L, that is a vector dot p vector, you can write p vector upon magnitude of p as p cap. So p cap is the unit vector along the direction of this AC. Clear? So now discuss the second point. Now in this case, suppose we have to find the projection of a vector on the projection of the other vector. Let A and B are two vectors. Okay, this is the vector A, this is the vector B, and we want to get the projection of B vector on this A vector. So projection of B vector on A vector will be B vector dot A vector divided by the magnitude of A, and this angle is theta, So projection of B vector on A vector equal to dot product of these two vectors divided by the magnitude of A vector. Means we want to get the projection of B on A, then we will divide the dot product by the determinant magnitude of A, and when we want to get the projection of A on B, then the dot product will be divided by the magnitude of B vector. Means projection of A on B equal to A vector dot B vector divided by the magnitude of B. I think now it will be clear to you all that how we get the projection of B. Projection is actually this line. Actually the projection is this length AC, and the projection vector is AC vector. So in this case, suppose you want to get the projection of B on A, then you will draw the perpendicular. You want to get this length, and this length will be obtained by the B cos theta, that is the scalar quantity. So this length will be B cos theta. Okay, now B A vector equal to magnitude A into cos theta. So B cos theta will be termed as the projection of B on A, and that's value is to be determined like this. If you want, then I can explain it further. Just see. Okay, this is actually B A may be written as B vector and A vector cos theta divided by magnitude of A. So this magnitude will be cancelled. Now you see B cos theta will be left, and B cos theta will be the projection that I have explained there. Here the projection of AB vector on AC is A cos theta. The same way here. Okay, so this point is clear to you all, that we can find the projection. Now let's consider, suppose that the theta is 0 degree. Okay, let's consider if theta equal to 0 degree, means the angle between the two vectors is 0 degree, or in the first case, suppose we consider the line AB, So in that case, suppose it is a line, it is AB and this is theta. So when theta is 0 degree, then the angle that is made 0, this theta is 0 degree, means AB will coincide on L. So the projection of AB on AB is AB itself. Okay, theta equal to 0, then projection of AB vector is AB vector itself. Now the second case, if theta is pi, suppose, and if theta is pi, then the projection of AB will be cos pi means -1, so the sign will change, minus AB vector. So in this case, when theta is pi, means the whole angle this in the anti-clockwise direction, it becomes pi. So AB vector will be just it will be seen like minus BA vector, minus AB vector, just opposite of AB vector. Clear? And last I want to discuss the two cases when the theta is pi by 2 and theta is 3 pi by 2. What would happen then? It is of A, B, C. If theta is pi by 2, means this AB is just perpendicular to the line, then there will be no projection at all. So if the theta is pi by 2, then the projection will be a 0 vector. Projection will be a 0 vector, and it will be the same in the case of 3 pi by 2. Okay, 3 pi by 2 case mein it's the same in the case of 3 pi by 2 also. So in this way we have discussed the projection of a vector on a line, how the projection of a vector is drawn, what is its magnitude, and different cases, 4 cases I have studied here, when the theta lies in the first quadrant, second quadrant, third quadrant, or in the fourth quadrant. Okay, between the 0 to 360 degree. Okay, so in the next video we will discuss about the cross product of the two vectors, and that will be the last concept that is to be discussed now. So I think you all have understood this. Okay, thank you.